Today we will be going over the composer interface available with VSim and demonstrating one of the VSim EM examples, Advanced Dipole Above Conducting Plane. This example demonstrates how to navigate the composer interface and use some of the new post-processing features available in VSim. First, to open the example, you need to select File, View from Template, click on the VSim EM Advanced Electromagnetics drop-down menu, and select Advanced Dipole Above Conducting Plane. We'll save it in the normal directory specified for VSim run spaces. This brings us to the parameter window. This allows the user to alter key parameters to a simulation very easily and rapidly. If you hold the mouse over a variable, a tooltip will appear giving information on what that variable is used for. For our first run, we will run the simulation using default values. So now we click the Save and Validate button to process the input file. Now we'll move on to the Run tab in order to run the simulation. Available in the left-hand pane are a couple of quick parameters in order to adjust the number of time steps the simulation runs for, the number of time steps between memory dumps, or if we want to restart the simulation, what dump to start it at. We aren't really worried about that right now, but we do want to click on the MPI tab in order to run this simulation with MPI using, in this case, 2 cores. Now we just click Run and wait for the simulation to run. We'll skip to the end. Now the simulation is finished running, we can move on to analyze the data in the Analyze tab. For this simulation, we're most interested in the far-field radiation pattern, so we select the far-field script. The dataset is the name of the run space. In this case, that is Advanced Dipole Above Conducting Plane. Num_phi is the number of phi points as specified in the parameter window at 120, as is num_theta at 60. RM refers to the lowest side lobe level. General all-purpose use is -40 dB. Normalize will, if set to 1, normalize the dB value so the highest is 1. We're going to leave it at 0. So we just run the analysis script, and now we can move on to the Visualize tab to look at the far-field pattern. Once we open the visualization for our run space, we click on our Scalar Data tab, scroll down to the Kirchhoff surface integral, that is the far-field radiation pattern, uncheck display contours, and we'll have the far field. Now, since the Advanced Dipole Above Conducting Plane example uses image theory to generate the infinite conducting ground plane, we need to clip the graph in half in order to get an accurate representation. In this simulation, we have the horizontally oriented dipole located one wavelength above the conducting ground plane. This will give us 2 lobes. Let's go back to the setup window and switch to a vertically oriented dipole. Now let's just click on our parameters, switch the orientation to 1 for a vertical dipole, save and validate, and rerun our simulation. Check to make sure that MPI is once again at 2 cores. Delete our old data, run, go to the Analyze tab, all our information is saved, so we can just rerun the analysis script, go to our Visualize, open it, navigate to Scalar Data, click on the Kirchhoff surface integral, uncheck display contours, and we can see that we have 3 lobes as the dipole is vertically oriented. This was a quick demonstration of the VSim composer interface and how to run the Advanced Dipole Above Conducting Plane example. Check back soon and we'll have more and further detailed tutorials on accessing some of the more advanced features of VSim.